Hello YouTubers and welcome to another episode of Cracking Irodov, in which I publish many of the solutions of this great many book of this famous author, the many talented Sir Irodov. And you know the name of my channel is Physics Lover. I have changed it from the Laughing Monkey Official HD a couple of days before and named it as Physics Lover as I am great in many love with physics. See, this wallpaper over here is my new wallpaper of my laptop. This one also involves some type of physics over here, the physics of fluid dynamics. And this is over here the wallpaper of this great many book, Problems in General Physics by Irodov. And today we will focus on question number 12 and we are going to crack it by flying colors. I think I am making more fun of the question. So let's focus on the question first. This question is very intuitive at first as this involves an equilateral triangle, and I think if it would not have been an equilateral triangle, then this question would have been many more type of complexities in this. So let's read out the question. 3 points are located at the vertices, means the edges of, not the edges, the endpoints of an equilateral triangle whose side equals A. Let me focus this, A over here. They all start moving simultaneously with velocity v, which is constant in modulus. Modulus means magnitude, with the first point heading towards continuously for the second for the third, and similarly the third for the first. How soon will the points converge? So let me first draw a triangle over here. Let me first draw a triangle over here to show how my triangle is looking. The question says that all the sides equals to A over here. And we know that each angle of an equilateral triangle is equal to 60 degree. So consider a situation after a small interval. I'm not writing it, please listen carefully. After a small interval tt, what will be the position of the particles as each particle is heading towards one another? So let me see. These triangles are not similar to each other at any means. Let me name them ABC. So after a particular time dt, the particles were heading towards each other like this, something like this. So this was vdt, this was vdt, and this was vdt. And if we think after some time by symmetry, all of these particles will meet at this centroid G, as this is an equilateral triangle over here. I think you should see that, you should visualize this thing in mind, that after some time they will meet at G if they are heading towards one another. By symmetry, of course, you have to write in this question, by symmetry, the particles will meet at the centroid of the triangle. Equilateral triangle, I would say actually. So we have to find out the time taken by all of these particles to reach this centroid of the part of the triangle G. And I don't know whether these particles do a party over there or anything else. I mean, considering what time they would take to reach G, what time for the transportation they will take to G, and after that they will do a party over there. I suppose they would do. So let's make another triangle over here to make this question more intuitive. If all of these particles will meet at point G, then that would mean we are mainly concerned with the displacement G. I think I should make another triangle over here. I hope that I will make a good triangle, big good triangle over here. ABC. Let me take out this particle. This particle has to reach this G over here. This G is the fundamental part of this question. G over here. Let me name this as D. So Bg is the displacement over here. If we know somehow what will the velocity from region from B to G, uniform velocity, we can directly put down the formula for time, that time is equal to displacement upon velocity in terms of vector formation. So let me think about what Bg would be equal to. we know that this whole angle is equal to 60 degree, and what about half of it? This would be 30 degree. And if at the initial moment it starts at velocity v, this velocity over here would be simply v cos 30 degree, as it's the as this is the component of this velocity over this here, and this is the party point of these particles. So what would be bg actually? Let me write over here cos 30 degree is equal to the base upon the hypotenuse, that's equal to bg. We are mainly concerned what's the length of bg over here. So bd was, this whole over here is a, so bg is actually a upon 2 over here. bd is, sorry, a upon 2 over here. Cos 30 degree is equal to root 3 upon 2. bd is equal to a upon 2 bg. So let me take bg to the left hand side, is equal to a upon 2 into 2 upon root 3, which in turns gives us a upon root 3. That's our bg over here, and our velocity component is equal to v cos 30 degree, and v cos 30 degree simply root 3 v upon 2. And we know that time is equal to distance upon velocity. So t would be equal to, distance was equal to a root 3, a upon root 3 actually, and that velocity root 3 v upon 2, that's give us a root 3 into 2 upon root 3 v over here, and that's our time equals to, our times equal to 2a upon 3v, 2a upon 3v, and that's our simple answer to this simple question, simple problem right over there. And if you visualize this situation in your mind, you will come to know why after symmetry they would meet at point G over here. So I think this question is very clear to you. This is the displacement, this is the velocity component over here, and we know that the time taken is equal to displacement upon time, and that equation we have used here. We came to know that the time was equal to 2a upon 3v, and the particles are doing a party over there now after time 2a upon 3v. And let's join a quest towards the next question. After some time I will publish that also. Thank you for watching these guys, and I think you would probably put on the like button over there. Thank you, and let's meet again.